In an equilateral triangle ABC, it is always true that the measure of ABC and BCA are what? So equilateral triangle, again, what does that mean? That's not exactly equilateral. Let's fix that. Okay, so that means that all the side lengths are equal and all the angles are equal. Okay, everything's equal. So if we're looking at any two angles, let's just say this is A, B, C. This question's asking about angle ABC, which would be this one, and then angle BCA, which would be this one. What do we know about these two? Well, I just told you that they're the same. So that's going to be that right there. Now, why do I know it's 60 degrees? Because the sum of the angle measures of a three-sided shape, aka a triangle, has to be 180 degrees. So this angle plus this angle plus this angle has to equal 180. If they're all equal, you can just divide by 3 and you get 60 degrees per angle. Just for some of the other options, sum to 90 degrees would not be correct because that means that you're looking at a right triangle. So for example, for any right triangle, you have one angle that's right. The other two are going to add up to 90 because this is 90, this is going to be something, and this is going to be something. In order for this to be 90, the leftover amount of angles, the leftover amount of degrees for the other two angles is going to be 90 in total. Sum to 180, that's not correct because the three angles sum to 180, not two, are each greater than 60. That's not true. They have to be exactly 60. And again, same thing here. In the figure below, BAC measures 40, ABC measures 90, and points BC and D are collinear. What is the measure of ACD? Okay, so let's just label everything we know. So this is 90 degrees. BAC is 40 degrees. So I can find this angle right here just doing 180 minus 40 minus 90, right? Because angle ABC, so angle A, B, and C all have to add up to 180, right? So A plus B plus C is equal to 180. So let's just, I'm gonna backtrack. Forget that for a second. A plus B plus C equals 180. And again, when I talk about C, I'm talking about this C right here, not this one. I'm talking about the inside one that's inside the triangle. Okay, so I know angle A is 40. I know angle B is 90. I'll just label C as C. That equals 180. That means C equals 180 minus 90 minus 40. 180 minus 90 minus 40. It's 50. Okay. Now don't choose, I mean, obviously 50 is not even an answer option, so you can't make this mistake, but just label this. And now, given that this is collinear, right? What does that mean? That means that BCD is just a straight line. And the angle measure of a straight line is always 180 degrees. Now, if I split this up by doing like an angle here, and I say this is 20 degrees, that means that the rest of this is just whatever's left over. That'd be 160 degrees. Because 160 plus 20 gives you 180 for the total. Same thing applies here. This entire angle measure is 180. But you have this section that's 50, so what's left over? Well, if you do 180 minus 50, you get 130. In any parallelogram ABCD, it is always true that the measures of this and this equal what? So let's just draw out a parallelogram A, B, C, D. So a parallelogram is any shape where it's a four-sided shape where you have the two opposite sides are parallel to another and the two opposite other sides are also parallel to one another. A square or a rectangle is also a parallelogram, but those are the unique case where the angles are 90 degrees, not like this case. And in the square, it's the case where all the angles are 90 degrees and the side lengths are all the same length. Okay, so let's just look at the ABCD and CDA. So ABC angle, oh, hold on, I guess I didn't label this correctly. ABC wouldn't be an angle in this case. They labeled it like this, okay? Because you have to go in sequence. Otherwise, you won't actually have an angle ABC. So angle ABC is this one, and angle CDA is this one. So because these are opposite angles of a four-sided shape, they have to be the same. And that's because the corresponding side lengths are parallel. So if I was to exaggerate this, make it a very slanted parallelogram, you're going to see that these two are the same. Just because the side lengths, if you were to do like the tangent ratios and identify the side lengths of each, you'll find that they're the same. This is just one of the basic rules of parallelograms. The opposite side lengths have the same length, and thus the opposite angles also have the same angle measure. Okay, so they're equal. All right, angle B and angle D are equal. Same thing with angle A and C, they're equal. In the isosceles right triangle below, AB is 11. What is the length in inches of AC? So we're told that it's isosceles and right. So let's interpret both of these. The right is the easy part. We see that there's a 90-degree angle there. Now, isosceles, what does that tell us? It means that there are two side lengths in this triangle that are equal to one another. And given that this is a right triangle, the hypotenuse must be the longest. Exclusively. There is no other side length that equals it. It is for sure 100% the longest. Okay? So that means if there are two side lengths that are the same length, it has to be these other two. That means this is 11. Okay? So we're asked to find AC. AC is the longest. You can either use Pythagorean theorem, just do a squared plus b squared equals c squared. In this case, this is a, this is b, and your longest is c. You can calculate it that way. Or you can just remember the fact that for a right isosceles triangle, if you have 1, 1 for side lengths, you would have square root of 2 for the... You basically just take the side length and multiply by square root of 2, and that is your answer for the hypotenuse. Now, none of the answers are... The correct answer is 11 square root of 2. None of them are in that form. So let me just do the Pythagorean theorem that should give us the right answer as well. So 11 squared plus 11 squared equals c squared. Just do c equals square root of, what's 11 squared times 2? 242. Okay, so it's E. Moving on along. If CAB is 130 degrees and DAB is 3/5 of CAB, what is the angle measure of CAD? Okay, there's a lot of things going on. So CAB is 130, then I'll do a different color. And DAB is 3/5 of CAB. So DAB is 3/5 of CAB. What's CAB? 130. So let's do 130 times 3/5. What does that give us? Open up my calculator. 130 times 0.6, 78 degrees. Okay? So DAB is 78 degrees. What is the angle measure of CAD? So CAD is just going to be right here. It's really just whatever's left. So 130 minus 78 is going to give you what's left, right? And that is going to be equal to 52. Quite simple. It's just a matter of this angle plus this one equals the total. The parallelogram ABCD has a perimeter of 40 inches. Angle DCB is 60 degrees and the length of DA is 12 inches. What is the area of ABCD in square inches? So let's first label the information that we know. So we know perimeter is 40 inches, DCB is 60 degrees, and DA is 12. Secondly, we should remember that a parallelogram is just two sets of parallel sides. These are parallel, as they look. Now, given that they're parallel, that means that the opposite sides are also equal. So this is also going to be 12. And I know that these two are going to be the same. We'll just label them x. X plus 12 plus 12 has to equal 40. That's just the perimeter if you add up all the sides. That gives you 2x plus 24 is equal to 40. Subtract 24 on both sides. 2x equals 16. X equals 8. Okay, these are both equal to 8. All right, now we want to find the area. So in order to find the area, we need to multiply base times height. The thing is, we don't know the height, even though we know the base. You can't just multiply 8 times 12 because the 8 is not actually the height. The height is whatever this value is from top to bottom. The vertical height that is perpendicular to the base, okay? And you'll if you multiply just by 8 times 12, you'll get a number that's too big, and that's just not going to work. And of also 8 times 12, that answer option isn't even there, so it wouldn't even just make sense. It wouldn't work. All right, so how do you actually do this? What you should do is take this little triangle right here. You know that this side length is 8, the hypotenuse. You know this angle here, so you can use the sine ratio to actually find the unknown side. Let me kind of draw that out to make it a little more clear. Okay, so this triangle right here corresponds to this section right here, okay? So we know 60 degrees. It's really just a 30, 60, 90 triangle. Hypotenuse is 8, and we want to find this. So if you remember your 30, 60, 90 triangle, then this will be familiar. So if I do sine of 60 degrees, that'll be equal to x over 8. I can solve for x using this. So multiply 8 on both sides. 8 sine 60 is equal to 8 times square root of 3 over 2. Which is just sine 60. If you do it on your calculator, you'll find it should be about 0.86 times 8. Okay, so that gives us the height. Now base times height is equal to 8 square root of 3 over 2 times 12. That gives you 96 square root of 3 over 2, which is equal to 48 square root of 3. Hence option D. So the perimeter of a triangle, an isosceles triangle, is 96 inches and the base is 26 inches. What is the area of the triangle to the nearest square inch? So first of all, what is an isosceles triangle? It's a triangle where any two side lengths are equivalent. Two sides, same length. Okay, so, and if I know the base is 26 inches, let's just assume that the two side lengths that are the isosceles ones are not the base. So let's call this 26. We're given 96 and is the total perimeter. So length 1 plus length 2 plus length 3 is equal to 96. I'll just say that the base is the length 1. Length 2 and length 3 are equal to each other. So really I can combine them and just call them length 2. Let's rewrite this equation. 26 plus length 2 plus length 2 again is equal to 96. Subtract 26 on both sides. We get length 2 times 2 is equal to whatever, again, subtract 26 on both sides, is equal to 70, okay? Length 2 is equal to 35. All right, so we have 35 here and 35 here. This is my isosceles triangle. Now, you think, we know that the area formula is half times base times height. So we might think, all right, I have my base, I have my height, why not just plug it into the formula? The issue is that's actually incorrect because this is not the height. The height is actually this value right here, whatever this distance is. And this is actually smaller than 35. So the best way to solve this is, since we know this is an isosceles triangle, this angle here, if I split this triangle, this isosceles triangle as such, this is going to be 90 degrees. So that would make this the hypotenuse of this right triangle. The leg here would be 13. It would just be half of 26. And then I just need to solve for the height, which is the last leg. So let's just plug in the Pythagorean theorem. Again, I know that the hypotenuse is 35 squared. I know one of my legs is 13, so that's 13 squared, and then h squared is the other b squared term. I can solve this by subtracting 13 squared on both sides. H squared is equal to 35 squared minus 13 squared. H is equal to square root of 35 squared minus 13 squared. H is equal to 5 to the second minus 169 to the 0.5. We get 32.496. That is my height. Okay, so we're not done. We got to take this and plug it into the formula. So area is equal to half times 32.496 times the base, which is 26, times 26 divided by 2. 422. That's the answer.
The ratio of length with corresponding sides of two similar
2 inches long. How many inches longer is the hypotenuse of the larger triangle? Okay, so let's take that back. We have two similar triangles that happen to be right triangles. So what does that mean? So let's just draw a generic right triangle. Now there's another triangle similar to this one, which means that it has the same angle measures, but it might just be scaled a little larger. It's like a larger size twin. Okay? Same angle measures. So this equals this equals this. And worth noting is these are both right triangles, as it says. Similar and right. Now the ratio of side lengths of the two corresponding similar right triangles is this. If the hypotenuse of the smaller triangle is 2, how many inches longer is the hypotenuse of the larger one? Okay, so we're told that the ratio is 5 to 8. So if for example, if the hypotenuse here was 5, this would be 8. But actually it's 2. So what is the actual hypotenuse length? We know that the ratio of 5 to 8 is going to be the ratio of small to large. That ratio has to always hold true for any of the side length pairs, like this pair, and this pair. Right? So if I just plug in the small, the actual small, and put the large as an unidentified x, and make this ratio equal to 5 to 8, I can solve for the x value. Okay? So 5 over 8 is equal to 2 over x. Let's do cross multiply divide. 5x equals 16. Divide both sides by 5. We get 16 over 5 is, I believe, 3.2. Okay? So the hypotenuse of the larger triangle is 3.2. 3.2 is not your answer. We're asked how many inches longer is the hypotenuse of the larger triangle. So it's 2 versus 3.2. Now what's the difference? It's 1.2. Okay? So it's a little bit of a gotcha question. The parallel sides of the isosceles trapezoid shown below are 12 and 18. What is the distance in meters between these two sides? So this is similar to problem number, where is it? 24. So it's really the same exact solution. You're just going to turn this into a right triangle where it's a similar solution, not the exact same. So we know this is 5. We know, okay, so since this is 12 and this is 18, the difference is obviously 6. And we know that this little section here has to be the same as this because these two are the same dimension. If these two were not the same dimension, then your parallelogram would actually look like that, where this one's shorter, this one's longer. In order for these two to still be parallel, that's just the way it would look like. So we know that these two dimensions are equal. They have to both be 3 because that's just the difference of 6 divided by 2. So this is 3. I can find this last side by doing the, this is the side that we're interested in, right? So I could just do Pythagorean theorem. So x squared plus 3 squared is equal to 5 squared. X squared is equal to 5 squared minus 3 squared. X is equal to square root of 25 minus 9, which is equal to square root of 16, which is equal to 4. Just a 3, 4, 5 triangle. If the divider shown by AD is 20 yards in length, what is the area of the hexagon to the nearest square yard? So if it's 20 yards in length, what is the area of the hexagon? So 20 yards. Keep in mind, it's an equilateral hexagon. So if this is 20, and let's just draw dividers everywhere just to visualize this. So we're told that the entire thing is 20. Note that this would also be 20 and this would also be 20. They're all 20. And that if I just look at half of it, since it's an equilateral hexagon, that means all the side lengths are the same. That means all the angles are the same. That means half of each of these is just going to be 10. 10, 10, 10, everywhere, okay? So area to the nearest square yard, we can just break this up into 6 equilateral little triangles. Okay, so if I know 10, 10, 10, and I know that the area of a triangle is equal to half base times height, let's just do base times height, right? Well, not really, because again, we had a problem before. It was this one, 16, where we're given the exact same scenario. We're given a triangle. We're given the base and another side length, but we don't know the height, and we need to find the area. Using that same approach, in order to find that, in order to use this formula, I need to identify height. That's actually going to be this value here, which is going to be less than 10. It's going to be less than the this other length. And what I can just do is turn this into a right triangle, because this is a equilateral triangle, right? So if I split this down the middle, both sides of it are going to be the same. So that means that this angle right here is 90. This becomes a hypotenuse. This is 5. Again, it's just half of 10. So I can solve this using Pythagorean theorem. A squared plus b squared is equal to c squared. Hypotenuse is 10, so 10 squared. B squared, let's just call that the, B is going to be my other leg, so 5 squared. And then A is just going to, we'll just call it A squared. Okay, so subtract 5 squared on both sides. A squared is equal to 10 squared minus 5 squared, that's equal to. And then A is equal to square root of 10 squared minus 5 squared. It's equal to 100 minus 25, square root, 75. 75 to the 0.5 is equal to 8.66. Okay. Now I can find my area. Area is equal to half times base, the entire base, not 5, but 10. 8.66 is equal to 10 divided by 2 times 8.66. 43.3. Oh, sorry, we're up. Oh, sorry. So, yeah, this is 43.3. Now, that's just 1/6 of this. We need to multiply that by 6. Area, so this area triangle, we need to find area hexagon. It's going to be 43.3 times 6. 259. It's 260. Okay? ray LM bisects GLD. The measure of GLT is 16x, and the measure of GLM is this. What is the measure of MLT? So there's a lot going on. So you have GLT. Okay, GLT. Let's do it straight lines. Then you have, I'll just call this GLT. Okay? Measure of GLT is 16x. And we're told that it is bisected by LM. Okay? So when it says it bisects, it really is just cutting it in half. So this would be 8x, this would be 8x. Right? Because 16x divided in half, 8x, 8x. Measure of GLM is 3x plus 10. So we can express it as 8x or 3x plus 10. What is the measure of MLT? It's, again, since it's a bisection, it's going to be the same thing. I can solve for 8x. I can solve for x here. Just say 8x is equal to 3x plus 10. Subtract 3x on both sides. 5x is equal to 10. X is equal to 2. All right, pretty simple. So 2 is not your answer. It's asking for the measure of MLT. That's just going to be 8x, 16 degrees. Okay, so again, the key is you just have to know what bisect means and identify that you're cutting this in half. According to the measurements given in the figure below, which of the following expressions gives the distance in miles from the house to the car? House to the car. Okay, so we have an angle, we have the adjacent side, and we want to find the opposite. That looks like tan theta equals opposite over adjacent. Okay, so let's do tan of 41 equals, I'll call this x, over 40. 40 times tan of 41 is going to give you x, 41 tan times 40. It's 34. 40, tan, 41. We don't even need the number. That is the correct answer. DC bisects BDE. BC bisects DBA, meaning it cuts the angle in half. And if the measure of DBA is 108, what is the measure of DCB? Okay. So a few things going on. These two are parallel, which means that this angle measure here plus this one have to add up to 180. Why is that? Think of it this way. So imagine you're on a car, you're driving this way, and then you turn right, now you're driving this way, and you turn right again, and now you're driving this way. What you did is a full 180 degree turn because you went like this, basically, right? And those two lines are parallel. Your starting line and your finishing line. So you had to have turned 180 degrees. Again, it's the same thing. It's the same reason why a straight line is a 180 degree angle. You're really just doing this angle measure here. So this angle plus this one add up to 180. All right. Now, why am I telling you that? Because you're going to need that piece of information to take this 108, extrapolate it, to find what's actually inside this triangle. The way you're going to do that is, first, since we know that this line bisects the angle, and the entire angle is 108, we can cut that in half and get 54 and 54. I'll put it in a different color. So 54, 54, okay? That means that, again, what's here is just going to be 180 minus 108, which is 72. This is 72. Again, we can cut that in half. You get 36, 36. So now I know what's inside this triangle, right? There's a, let's draw that a little better. There's a 36 here. There's a 54 here. So I can find the remaining. This is just going to be 90 if you do the math. Okay. So it's a 90 degree angle in the middle. Interesting how that works out. Really, it's because it's bisecting two angles that add up to 180 degrees. All right, hopefully that made sense. What is the period of the function f of x equals tan 2x plus 4? Note that the period of y equals tan x is pi. So you're generally told that, the period is equal to 2 pi over b. In the case of this, your b is 1. But what it's telling you is that tan is kind of an exception. It doesn't really follow this rule. So I would ignore that. What I would just do is just graph this. If you graph it, you'll notice that tan, y equals tan x, looks like, if I just put this here, this here, this here, this is pi, 2 pi. Y equals tan x looks like this. It's just It's not a very accurate drawing, but you get the point, okay? All right, and then y equals tan of 2x looks like this. It's basically just double the frequency. So the period is halved, okay? So instead of having a period of pi, now you have a period of pi over 2. The figure below shows a laser beam pointing at the moon. At a certain moment, the laser beam forms an angle of elevation of 80 degrees from point X on the ground. At the same moment, the angle of elevation of the moon to point Y is 35 degrees. The distance from point X to the point Y is 4,000 feet. What is length in feet of the laser beam to the nearest moon, to the nearest foot? Here to here is what we're looking for. We're told the angle of elevation is 80 degrees. From the moon to the point Y is 35 degrees. And point X to Y is 4,000 feet. Okay, and we want this distance right here. So how am I going to get that? First of all, when you're given two angles, you can immediately solve the last one because it's a triangle. So just do x plus 80 plus 35 is equal to 180. Subtract 80 and 35, we get x equals 180 minus 35 minus 80, 65, okay? So I know this angle here is 65. I've immediately made this problem a lot easier. Now what I can do is I can use law of sines. Law of sines is very useful when you have three sides and three angles and one side, or three sides and one angle, okay? So let's just say this is angle z. Let's just say sine of z over side length z, which is opposite it. So this is going to be side length lowercase z. This is going to be side length lowercase y. This is going to be side length lowercase x, because they're all opposite each other, okay? Understand the opposite bit. It's just which side does the angle kind of open up to. So sine z over z is going to be equal to sine of y over lowercase y. So sine of angle z divided by the side length z is equal to the sine of angle y divided by the side length of y. Okay? We know everything in this equation other than the side length here. So I can just solve for that. So let's just plug everything in. Sine of 65, which is angle z, divided by the opposite side length is equal to sine of this angle 35 over this side length. We'll call it, just call it y. All right. Now I can just do cross multiply and divide. Y sine 65 equal to 4,000 sine 35 divided by sine 65. Y is equal to, so let's do 65 sine, multiply that by, hold on, we have to do 35 sine divided by 65 sine times 4,000, 2531. Yep, it doesn't seem like the numbers really make sense given that the moon is quite far away. But according to this problem, the moon is 2531 feet away. So whoever wrote the problem, good job. I don't know what planet you're on, but that's the correct answer here. So hopefully that method made sense. The idea here is just using law of sines to leverage the information you have and identify what you don't have and solve using the equation. If you want the whole equation, it is sine of angle A over side length A is equal to sine of angle B over side length B is equal to sine of side length angle C over side length lowercase c, okay? So it's an interesting relationship between all the angles that you can use given what knowns you have. In this case, we had two angles and a side. We were able to find the last side. Okay, that's really how it works.